everybody. It's Tuesday. Yes, it's Tuesday today, even though it's not Tuesday. But let's pretend it's Tuesday. No, today is Tuesday. And today is a very exciting day for the Service Bus team and for me because something magic happened. We made something up and we shipped it. And what we made up was called Iguazu. I talked about that at the conference, the Build conference, 1.5 years ago. And meanwhile, Elio Damaggio has taken the charter and ran with it, and with a team of folks, and turned that prototype into something real, and that is now called?
Service Bus Notification Hubs.
Service Bus Notification Hubs, exactly. So notifications are different from all the other things we have in Service Bus, and they're familiar to people who have been using the Windows Azure Mobile Services. So explain to me what notifications are.
Basically, the main big difference between notifications and other things that Service Bus does is that in this case, basically Service Bus contacts some platform-specific infrastructure to deliver this notification to the device. So everybody is familiar with smartphones, so iOS, Windows 8, Windows Phone, Androids, they all support push notifications. All those platforms provide a different platform notification service, which allows you to send a notification which then pops up on your phone when you're not expecting it. And when the app is not expecting it, that's the most important part. And all these platform notification systems are different, have different abstractions. They all work more or less in the same way, but with enough differences that makes coding against all these platforms very big hassle for people in the mobile development.
So generally, if we have a device, so let's go into and make a device how they usually look. I would draw this in yellow if I was drawing my device, because I have a wonderful yellow Nokia 920. But otherwise, all the other devices are all black, so that's the appropriate picture. So I have my device, and I run some kind of operating system on it. And depending on what the operating system will be, at some point I get, if I send a notification, some kind of alert. So Windows Phone kind of makes a little toast up top. Windows 8 makes a toast kind of in the corner, and then iOS gives you these pop-down things now, and Android can also, the Android thing does the pop-down because the guy who made this in Android then went to Apple, I think. So that functionality is one of the shell.
Yes, so basically push notifications are received by the operating system. With Android is a little bit different, but in general the app doesn't have to be active and doesn't have to hold the connection to basically receive the notification. This is how the whole platform notification services work. So if we want to complete the picture here, when you have an app inside your smartphone that usually talks with an app backend, and this app backend here cannot directly.
You need to get out of the way of your picture.
Cannot directly contact the app because the app cannot run in the background. So what happens is that there exists a platform notification system, which we usually call PNSs, and there is one for every platform, one for Windows, one for Windows Phone, one for iOS, and one for Google. And then what this platform does allows you to reach the operating system. So if you're an app, so there exists an app like Elio app, I can talk to PNS and say I want to push the notification to Elio app. Now, how does this work? This works in this way. Elio app on the smartphone has to contact the PNS, which then provides some form of handle, like we call them. There are device tokens for people familiar with APNS, channel URIs for people familiar with Windows 8. This token here has to go back to the back end of your app. And then when you want to send a notification, the app backend talks to the PNS with the token and with my app credentials, which basically tells the PNS that I'm really LU app, and then and the PNS will then will have this magical toast appear.
Yes, the one of the reasons why this is a pattern that's repeated across all those systems is that this here, really this link, is a single precious socket that's being maintained by the phone against one point against the push notification system. Because if the apps would do this all by themselves, everybody would maintain their own socket. What that would mean is that this antenna here in the phone would never go on low gain, and it would remain active all the time, which means your battery would burn down in an hour or so. So what they do to extend battery life, just for energy efficiency, so that you can actually make your phone last through a day, is they only have a single socket that they maintain, and that single socket is actually maintained by pinging only about every 20 minutes or 30 minutes. And all the operator networks, so the wireless networks, are actually optimized so that their NATs are optimized around that case. So we can take the same picture and just make this. So this could be APNS, this could be Windows, this could be all the other ones. They all have the same picture. Now, there's differences.
There's differences. The thing is that the main problem with this approach is that when you have a multi-platform app, you have to contact all the various PNSs. Also, all these tokens here basically accumulate somewhere in your database. You usually have like a big table with a lots of tokens. And actually, you have these tokens, you have this channel URIs, you have to keep track of which is what, by user, by installation ID. There's a lot of stuff going on here just to send these push notifications.
And multi-platform doesn't mean that you're doing something exotic. When we used to talk about multi-platform, you would say, I'm building a Windows thing, and then I'm building a Linux thing or an Apple thing, and they would be completely different and separate. But the world has changed so that you have a system that sits in the back and speaks something and is built on some platform, and we certainly hope that it's on Windows Azure, of course. But the clients are the clients that exist in the world, so there's no denying, even though we work here at Microsoft, that Apple is actually doing pretty well. And so that they're selling a lot of devices, and a lot of people have iPhones and iPads, and we have our own operating systems, with Windows not being the smallest of them all. And so you have this variety of platforms that are sitting on the client, and that's something that's just part of the real world. That's not a choice that you make. If you want to reach consumers, or if you want to reach even a mobile workforce, bring your own device, then the cross-platform nature of this piece here is normal.
Yes, so the cross-platform is really, really important in mobile. You want to reach all the devices possible, and the problem is that this architecture really forces you to deal with a lot of extra complexities that are really not related to your application, they're related to the fact that you have to interfaces to these multiple platforms. You end up like managing all these tokens. You end up managing all the credentials for this platform notification systems. Also, all these platform notification systems they all more or less support the same basic functions, but they all do it in a slightly different way. So yes. Basically, what this thing becomes, if I can use other colors, you will have another PNS with another interface here, and another PNS and another interface here, and in here you have different kinds of tokens in this table. And every time that you have to send a message, you have to figure out who you want to send it to and talk to the right person. And of course, this is something that doesn't scale very well.
Yes.
And this is one of the problems that we want to solve. We want to give you a way to not have to deal with these tokens and with this multiple interfacing problems. We want to abstract these whole things.
Yes, because turns out if your application needs to scale to hundreds of thousands of clients, and that's something that's not utopia for a lot of scenarios. Just because very many companies now that we have these these apps that go onto the iPhone and onto the phones and the Androids, a lot of consumer-facing companies. Let's forget the news providers because they're kind of obvious. There's MSNBC or NBC News now. There's CNN. There's all those news organizations. ESPN, which obviously have all that reach. And then there's just consumer goods companies, which now kind of start interacting with their customers in special ways, offering special deals, notifying of special events, etc. So all of those have kind of scaled to hundreds of thousands, certainly millions of customers, and then a subset of those customers, but certainly aspire to have hundreds of thousands of clients through those apps. So these are enterprise apps. They're enterprise apps. They're kind of a terminal into the enterprise in the consumer's hands. So those scales exist, and now there's a problem starts arising with the scale of this thing, because now all of a sudden you need to maintain backends that are scaling to hundreds of thousands and managing those kinds of push notifications just because of all that housekeeping. So therefore, we introduced this fantastic new feature called notification hubs that's designed exactly to solve all these problems. You do not have to store this device information in your database anymore. We will do the sharding. We will keep them up to date, and we will also make sure that when you have to reach all these hundreds of thousands and millions of devices, they receive it in a reasonable amount of time. Also, of course, there's a cross-platform bit. So there's on the device, and in the beginning, we support iOS
and Windows 8.
And Windows 8.
But by the time we go GA, we're gonna have, which is general availability, Microsoft jargon. We're gonna support Android and Windows Phone too.
Yes. So we have an SDK for the device that kind of wraps around the native API with some inputs that you need to provide. But effectively, we're creating the same kind of interface for the API, and we also create that abstraction natively on iOS. So yes, we've been sitting down and writing Objective-C code.
We did.
Yes. And so we create a fairly aligned, similar. I mean, Objective-C is not C#, so things are going to look different. But the abstraction is kind of the same. So we register on your behalf. So you give us, we do the registration. So we go to a backend, and that backend is now not your own app, but it's Service Bus. And you register with the thing that we call the notification hub. The notification hub is like we make queues and the topics and relays in Service Bus. We have created a new thing, and that new thing is called that notification hub. So that notification hub now makes this here unnecessary. You no longer need to go and register, keep all these registrations here. And what it also does, it does all the necessary housekeeping. So when the application comes up, it goes and renews its token because the tokens can change. And so the re-registration and making sure that the old one replaces the new one and all that magic, all that's done kind of by that link into Service Bus, and it's done in cross-platform fashion. So a registration that's coming from iOS is the same thing as a registration that's coming from Windows 8, same thing that's coming from Android. And so all those registrations sit here on that notification hub.
Yes. Now, usually the first question that I have is that, okay, if I do not have the tokens or the shiny URIs, how do I tell Service Bus what devices I want to send my stuff to?
Yes.
So the solution to that is that when you register, you basically assign a set of tags, which are just strings, basically identifiers, and you do not have to pre-provision them. So you just come up with names that make sense in your in your app. They can be user IDs, they can be interest groups. ESPN might have different teams. I'm not a sports fan, but Clemens here will gladly come up with a number of teams that make sense.
Yeah, so we could talk about Borussia Mönchengladbach, my football team, and Lazio Rome.
For instance.
Yes, which you're an AS fan, as we found.
Let's say that. Yeah.
Yes. Well, you told me that you're not a Lazio fan. That's probably
No.
we have a game coming up in the European Cup, so you better not be a Lazio fan.
Okay.
So yes, so there are teams that you're particularly interested in. That's the device can actually go and set this before knowing any messages. It can set a set of tags.
Exactly.
Onto with its registration.
Exactly. Other things that that can be used are usually things like it could be like customer age, if people want to target notifications to customers of a certain age, interest groups, so teams that you're interested in, or user ID if you actually want to target a specific user. The great thing is that the same user might have one Windows 8 tablet, one iPhone, and a Nexus 7, and they will all register for their user ID, and the backend would send one message targeted at that user ID, and all the notifications will flow to all the devices.
That's right. So I have here, as an example, Seahawks, Mariners, and Sounders as names. We're in Seattle, and so if a message shows up here and that carries the tag for Seahawks, this will be selected for this.
Exactly.
So there's a huge filter engine, effectively, inside a service bus here that's dealing with those things. So you have one notification hub, and you have 10,000 devices hooked up to that, or 100,000,
Even more?
or even more. Do we have a limit?
We do not have a limit right now. I mean, in preview, of course, we do.
Yes.
That's because the feature is in preview. But in GA, the limit will be very high in the millions.
Yes. So you can hook up all those things, and then if you have really the the single user multi-device scenario, where you really want to send a message to someone, each of the devices will go and hook up and register and set the tag that is equivalent to the user, and you can target that message. We're selecting then, let's say 4 or 5 out of 5 million, and that's automatically done. That's the pops up kind of functionality that we have inside the service bus for this. So this tag feature is an enormously interesting one. Combined with effectively the scale that we have, what you get out of a notification hub is effectively a huge fan-out mechanism, a huge way of hooking up all these very, very many kind of devices and then filtering them by tag. What you will practically do is you will use them as unfortunately the term topic is burns.
Yes.
But
It's essentially the same thing.
It's a theme. It's something that is like some logically related things will be usually grouped in the notification topic, but you can actually go and use that as a mechanism. What you will pay, the more tags you make, the more complexity you add, the more you will impact your flow rate, your throughput. So keeping things at a reasonable level of complexity is actually going to help your application. So of course, this also works by if we leave the tags out, or just say, let's assume every machine would have its own, every machine would set the same tag.
Yeah, that basically there is a way to basically send like a broadcast to all the devices that are registered. That is always available. If you do not want to use tags and you just need pure broadcast scenario, then basically notification hubs act exactly like a topic.
Yes. So what we do, one of the things that we do, kind of the magic that we built, and that's fairly significant. You can obviously build a broadcast yourself. So you make a table and you put 100,000 rows into it, each with a channel URI, and then you build a smart for each loop.
Yes.
And you go over them. The problem with that is that every send is going to take a while, and every repeated send is going to take a while, and then you might abort, and you might crash, and you might be shut down, and it's going to take a long while. What we're optimizing the system for, one of the pivots we're optimizing this functionality is delivery time. So we will go abroad, and you send us a message, and what we will do is we'll try to optimize as much as we can around for delivery time, because we've been, actually the first attempts that we did were threatening to take down the Windows 8 push notification infrastructure, because we can effectively scale, we can create parallelism that would allow us in theory to deliver 5 million push notifications at once. The problem is that the push notification systems that we're working with don't quite allow that. So as hard as we can push against them, that's as hard as we push, so we create as much parallelism as we can, so that if you send one message, it actually hits all those registrations, so we can get that as fast through as we can.
So basically when the Seahawks score, you know it in a minute and not in half an hour.
Yes, or you should know it as soon as it happens, and so we're trying to make it as fast as anyhow possible. And the faster it is, actually, the latency is a cost factor effectively. And so we're trying to optimize. We're trying to optimize for the case of making those things really fast. So broadcast is something that is broadcast at that scale is a fairly unique feature. If you look across, there's a number of competitors obviously in that space around push notifications. But if you look at their APIs, generally. You can send to a few groups, so you can go and create a package. You manage those subscriptions, you make a package, and then you kind of do a source routing thing where you say, go take this message and send this to the following dozen, hundreds of things. But this is a fairly unique approach in that we're actually maintaining millions of subscriptions for you. Send us one message, and then a message goes through. Now, let's talk about that one message, because we have something interesting there as well.
Yeah, so basically, as we said already, all the different platforms have different interfaces. Some of them use TCPs, most of them use REST. The exact protocols is all different, but that's not exactly the main problem. The main problem is that the feature that they support are actually different kind of notifications. So for instance, Apple supports iOS, let me be more specific, supports toasts. So that those are the little messages and alerts
Yep.
that come up, and the badges on your app icons.
Badges are these things. So you have this app icon, and then in the corner sits
a 3, a 2, or something.
A number. Yes.
Yes. So something like that. In Windows Phone supports tiles. Windows Phone 8 supports a huge variety of tiles and a huge variety of badges too.
I think 28.
It's much more than that. It's much more than that. Many kind of tiles, and also like many features. You can rotate notifications on the same tiles and all this sort of things. We did not want to go and create like the minimum common denominator across all these platforms. So what we allow you to do is basically we allow you to specify exactly how you want to receive the message, and then we let you send a platform-independent message.
Yes.
How does this work? Let's make an actual example with iOS and Windows 8.
Okay.
I can iOS. The format is if you look after all the TCPs, expiry, big endian. Problems that are there. Well, problems is kind of anyway. what exactly in the end you're sending a JSON payload that is usually something that looks like this. It's APS. You put here your alert, and you usually have something like hello, and then you can basically just say I'm done with APS. Sometimes you put some custom content in here, sometimes you want badges, sometimes you use localized strings, so these things become more complicated.
Yep.
But basically this is like the basic stuff. In Windows, what you do is that you have the analogous version is one of the templates, which is TextToast04. Don't ask me why it's the fourth one, but it's the fourth one, the one that only has one text. And basically has lots of XML elements. There's one of them that's called binding, and that has a type.
Yes.
And here
I
you
can
will
tell
say what it is.
I can tell you're a doctor because you're writing like one.
Yes, I'm terrible. I'm sorry. But inside this XML, there will be something that's called text and ID 1.
Yes.
And in here, I will have my hello.
Yep.
Now, what's the problem? Is that those things are completely different, but in the end they're doing the same thing.
That's right.
Usually what you want to do from your backend is that you just want to say, I want to send hello. And so what we're doing, we allow you to specify when a particular device registers to Service Bus, it specifies a template. So in here, instead of hello, and we'll just say, well, I just want to send a message.
So you can say here, dollar.
Message.
Message. So you take the. So now we're doing something. We're doing something which is a little bit mind bending. All push notification systems, if you go and look at the documentation, will tell you that the server sends this message. We're turning the tables on all the PNS systems, and what we're doing is we're saying, the client, which actually has the entire experience with it, right? The UI, the UX as we call it, the user experience, is all encoded in the client. It seems fairly silly, if you think about it, to actually take a piece of that client experience, of which push notifications are an integral part, and move the design and how this looks onto the server. So what we do is as you register from the device through this API, you go and construct your notification message as you want to receive it on the device, and then you give that to us, and in the places where you expect content, that's where you put this little expression language that we have devised, which gives you kind of placeholders in strategic places. So we do this here, and then you do the same thing here, dollar message. So effectively, the Windows device does that, the iOS device does that, and they're registering from their perspective, from the client with our system. So now we have stored.
In here, there will be two registrations. One for Clement's iPad.
Yep.
And here there will be this template.
Mm-hmm.
And then we'll have Clement's Surface.
Yep.
That has this template.
That's right.
So two registrations. One that has the token, and one that has the channel URI.
That's right.
Which will be.
And we'll associate, so in your application, you can choose the tags as you like, but what you would do is you would probably, if you want to push to me, if you want to alert me, then you can send the filter that we talked about earlier, to my user ID. And now my apps, the two different apps that I have registered with the same gesture, for the same gesture, the same toast. The Surface app registered for a toast that it wants, and it actually can choose whether it wants to have a toast or a tile, and it can choose what kind of tile it wants. So effectively, you give us what you want, and we'll push that back to you once we have data to do the mail merge with it, because that's the next step. Service Bus messages that we're using here, but we're using a bit of an abstraction to make it not too much service busy, to make it approachable, effectively are a set of key value pairs plus a message body. And the way we shape the API right now is we basically just give you a way to send a
dictionary.
A dictionary, key value pairs, right. So what we do is very simple. You send us a key value pair under the covers that's a Service Bus message. And that message comes into, it comes from here.
From here.
Yes, see there. We have a place. I was confused. So you send that to the notification topic, and what you send is key value pairs with message being hello. And now we do a scale out mail merge with all these templates. So you register 1,000, 10,000, 100,000 templates. We take the source message, we take the key value pairs, and merge them in each of these templates as the application wants it and push them out. You can also go and do this natively, so that's the alternative that we have. If you like to have control from the server, which some people want, you can actually go and then filter by platform.
Yes.
And go and say, okay, so now I want to send a tile to all registered applications that are sitting on on Windows 8, and you can take control from the server and basically just give us the native payload. We're going to deliver the native payload to everybody. But the preferred model is the one where you turn the table and actually have the device register exactly what it wants. And one of the nice things that we've done, I think, specifically on Windows 8, is we take the native API to make toasts, and the native API to make tiles, to render all these XML islands. And as you would do it in the local programming model, because if you have a local app in Windows 8, you're use that API to actually render how the tiles should look, and then you give that to the shell. Exactly that same API we use, and then instead of putting content in there, you put our little language in there, and then you effectively render this out, and you actually don't have to worry about the rendering out, because we actually take that native object as you register, and then we pass that to the server. So we do effectively all that work for you.
Basically, if you're familiar to do local notifications, which usually if you're doing push notifications, you're already doing local notifications, and this works both in iOS and in Windows 8. The same motions that you would do to basically create a local notifications and then display it, instead of displaying it, you just register with it.
Yeah.
It will be like the same exact motions, the same exact content, and that is another value of this approach.
Yes. So effectively, if you have a service, and the service is pushing data out, and that's the concern that it has, right? It wants to notify users. It wants to notify users mostly, right? This is what this is about. You want to catch someone on their device, and you want to notify them. It's not so much about wanting to notify a particular device and the particular platform that's on. If you have that, then you need to have some kind of abstraction, some kind of indirection. That's something that we have built straight into Service Bus with those capabilities. So the next thing we're going to do is we're going to go and do a screencast, and we'll show people how to do this in practice.
Of course.